Hey there and welcome to the world of maths. In today's lecture we are going to learn about these quadrilaterals. Let's begin our learning by splitting the word into its original meaning. That was awesome, isn't it? This word quadrilateral made up of two main words. Quadri, which means four, lateral means sides. Isn't it, Sonu? Will you try it? Yes sir, why not? Now only you told quadri means 4 and lateral means side. So diagram with 4 sides is called as quadrilateral, isn't it? Actually, whatever Sonu said is not wrong, but it is incomplete because if those sides are not closed, then it cannot be quadrilateral. These sides, we cannot say just diagram made up of 4 sides. Then it can be like this also. And this thing is not a quadrilateral, isn't it? Yes. Any quadrilateral has 10 important parts. These parts are also called as elements, and these elements are nothing but 4 sides, 4 angles and 2 diagonals. We can say a closed diagram with 4 sides can be termed as a quadrilateral, and in detail, if you want to say or if you want to understand it, a closed geometrical figure which has 4 sides, 4 angles and 2 diagonal is called as a quadrilateral. In short, these quadrilaterals are two-dimensional diagram. Two-dimensional means they have length and breadth also. A diagram with 4 sides, 4 angles and 2 diagonals. Correct? Excuse me sir, will you please tell me the meaning of diagonals? Why not? Diagonal is nothing but a segment, or you can say line segment, that joins two opposite vertices of any quadrilateral. That means in the diagram of the quadrilateral MATH, M and T are the opposite vertices and segment joining that MT is nothing but a diagonal. So in that manner we have two diagonals, one is joining M and T and another one is joining A and H. Boys and girls, these quadrilaterals are mainly or broadly classified into 3 main types, that is parallelogram, trapezium or also called as trapezoid, and third one is kite. And all these 3 are defined by a unique link. In parallelogram, all opposite sides are parallel. In trapezium, only one pair of opposite sides is parallel, the way you are looking at the screen, and in a kite, no opposite sides are parallel to each other. Isn't it nice? Keep it in mind because it will be very helpful while solving few numericals. So now we will try to understand the meaning of each of this type one by one, including its definition and properties too. So here we go with the parallelogram. First of all, the name of the parallelogram is MATH. Always remember that we have to name the quadrilateral either clockwise or anti-clockwise. Clockwise, the way you are looking at the screen, and here it is the naming in anti-clockwise sense. Okay. A quadrilateral in which opposite sides are equal and parallel is called as a parallelogram. So if you look at the diagram, you will come to know that side MA is opposite to side TH. Both shows same marks on them to make you understand that they are equal and they are parallel also. Same goes with MH and 82. They both are equal and both are parallel. Here we go with the properties of parallelogram. The first property of the parallelogram is nothing but the definition itself. Opposite sides are equal and parallel. The second property is about the opposite angles, and it says that opposite angles are congruent or equal in measure. The third and the most important property is about the adjacent angle, and it says that adjacent angle of the parallelogram are supplementary. That means if you add these angles, your sum will be 180 degree. And the last property of the parallelogram, and which is very important actually, about the diagonal, it says that diagonals of the parallelogram, they bisect each other. Bisect each other means they divide each other into exact half part. Okay, so point O in the diagram, that is on the diagonal, okay, is nothing but the midpoint of those diagonal. That means the diagonal for diagonal MT, point O will be acting as a midpoint, and same goes with diagonal AH too. Now I'll give you a tip to identify adjacent angle. Okay, if you name any side in this diagram, suppose side MA, all right, so this point M and A are nothing but are making adjacent angles. So angle M and angle A are nothing but the adjacent angle also. So if you say side TH, that means point H and point T are nothing but the adjacent point, and that makes them adjacent angle also. So keep it in mind, for the adjacent angles you have to just move on along with the sides. The name of the side shows or indicate the adjacent angle also. For the opposite angle, keep it in mind, the name of the diagonal gives the hint for the opposite angles. So name of the diagonal over here is MT, and so point M, that is angle M, now will be opposite to point T, that is angle T. Isn't it easy? So in short, for the adjacent angle, remember the name of the side, and for the opposite angles, remember the name of the diagonal. Here we go with the next quadrilateral on your screen, that is trapezium. And for the better understanding of the trapezium, the naming is kept same as that of parallelogram. That is M, A, T and then H in a clockwise direction. The definition of the trapezium says that a quadrilateral in which only one pair of opposite side is parallel, then it is called as a trapezium, or also called as trapezoid. Over here in the diagram, MA and TH are nothing but the parallel sides. If you remove these two sides, then which are the two non-parallel sides? Yes, of course, MH and AT are the non-parallel side, and these non-parallel sides are called as legs of the trapezium. Non-parallel sides are called as legs of the trapezium, and the property of the trapezium is related to these legs only. The angles formed on these legs, so one leg is MH, right? So angle M and angle H are nothing but adjacent angle. Similarly, on the other leg, the angle form are angle A and angle T, that is AT. These two adjacent pair are supplementary, and only these two are supplementary in the trapezium. This is what the property says. Only two pairs of adjacent angles are supplementary in the trapezium, and over here it is MH, angle M and angle H. Similarly, angle A and angle T are nothing but the adjacent angles which are supplementary to each other. The next quadrilateral on the screen is nothing but the kite. The way I explained you previously, according to the common link, here in the kite no opposite sides are parallel to each other, but in the definition we are not supposed to take that into consideration. We will be defining this kite based on the diagonals. Okay, so what does the definition says? When in a quadrilateral, longer diagonal is perpendicular bisector of the shorter diagonal, then that quadrilateral is called as a kite. Longer diagonal must be perpendicular bisector of the smaller diagonal, and then that quadrilateral is called as a kite. And in the diagram, if you observe, MT is the longer diagonal, whereas AH is the smaller diagonal, and MT is nothing but perpendicular bisector of that AH, and that is why this time MATH is nothing but a kite. The property of the kite says that, very first, no opposite sides are parallel to each other, that is what the link said. After that, only one pair of opposite angle is congruent. Keep it in mind, only one pair of opposite angle is congruent. And second property says two pairs of adjacent sides are congruent to each other, the way you are looking in the diagram. So boys and girls, these are the three main types of quadrilateral. Okay, but isn't something missing from this? Where are the square, rhombus and rectangle? Are old friends. Isn't something missing? Yes. Before proceeding further, just try to observe the front cover of your maths textbook. Over here, what do you observe? Basically, at the bottom we have a quadrilateral. Above that quadrilateral, it's a parallelogram. Above that parallelogram, two diagrams are given. One is rectangle and other one is rhombus, and on both of them, okay, again small quadrilateral is given. It is nothing but the square. What does it indicate? This diagram is to give you hint that the chain of the square, rhombus and rectangle is derived from a parallelogram. That means all these rectangle, square and rhombus are nothing but the types of parallelogram. So here we go with the next understanding or the classification of parallelogram further on. Figure on the screen that you are observing presently is nothing but a rectangle, and for the better understanding, the naming is kept same as per trapezium or the parallelogram. What the definition of the rectangle says? Rectangle, right angle, Is there any link? Yes, of course, the definition provides that link. Any quadrilateral in which all angles are right angle or each angle is 90 degree is called as a rectangle. If each angle of the quadrilateral is 90 degree, then we have to say, or it can be termed as rectangle. Here we go with the properties of the rectangle. Now the very first property is nothing but opposite sides are equal and parallel. Second property, every angle is 90 degree, so we can say all angles are equal, correct? Third and the important one, diagonals of rectangle bisect each other. That means same part. Point O in the diagram, okay, nothing but midpoint for diagonal MT and the other one also, that is AH. Okay, the last property of the rectangle is nothing but the extra one which is added to the parallelogram. You can say diagonals of rectangle are congruent. Keep it in mind, diagonals of rectangles are congruent. That means the value for MT is nothing but equal to value of AH. If you compare this property with the properties of parallelogram, you will find each and every property lying there with the properties of rectangle. Even the adjacent angles are also supplementary, because every angle is 90 degree. That means if you add any two angle, of course my answer will be 180 degree, and that makes them supplementary also. So as every property of the parallelogram is there or present in rectangle, that is why we can say every rectangle can be termed as a parallelogram. And this is why I told you that all the properties of the rectangle are similar to parallelogram, or rectangle is derived from the parallelogram, but only one property is added to it, and that property is nothing but diagonals are congruent to each other. Here we go with the next diagram on the screen, and that is rhombus. And for the better understanding, again the naming is kept same, that is MATH. In rhombus, if you observe, each side is given same mark. That means every side is equal in length. Okay, so what does the definition of rhombus says us? If in a quadrilateral each side is equal in measure, then that quadrilateral is called as a rhombus. Keep it in mind. And this rhombus, the way I told you, is nothing but one of the type of parallelogram. So every property that we see in parallelogram is repeated over here also, but it is given one special property too. We'll see to it. Over here the properties of rhombus are, the very first, each side is equal in measure, opposite sides are parallel, the way it was there in the parallelogram. Okay, what, see, in parallelogram opposite sides are equal. Over here all sides are equal, then ultimately opposite sides are also equal, and that is why we can say the property of the side of the parallelogram is present over here in rhombus too. So here we move ahead. In parallelogram opposite angles were congruent. Over here also in the rhombus opposite angles are congruent in nature. Parallelogram, diagonals bisect each other. Over here also diagonals bisect each other. And which is the most important now added one? Diagonals in the rhombus are perpendicular to each other. This is what the added property is. And all these added properties of the rectangle and the rhombus are shown in the advanced parallelogram is nothing but the square. Boys and girls, the diagram that you're looking at the screen is nothing but the square, and that is square MATH. Okay, and the definition of the square says that if in a quadrilateral each side is equal and every angle is equal in measure, that is 90 degree, it has to be 90 degree, then that quadrilateral is called as a square. And if you observe the properties of the square, you will come to know that each and every property of rectangle, rhombus and the parallelogram is present in the square. So which are those properties? As every side is equal, property of rhombus. As every side is equal, that means opposite sides are also equal, that is the property of rectangle and the parallelogram, correct? In a square every angle is equal, that is each angle is 90 degree. If each angle is 90 degree, property of rectangle comes over here. As all angles are equal means opposite are also equal, so property of rhombus and parallelogram is also present. The next one is diagonals bisect each other, property of parallelogram. Diagonals are perpendicular to each other, property of rhombus also is present. diagonals are equal, property of rectangle is also present. So all these properties make the ultra parallelogram, that is square. Isn't it nice? So in short, what we have learned today, we have learned that the quadrilaterals are classified into three main parts, that is parallelogram, trapezium and the kite. Further, parallelogram are subgrouped into rectangle, rhombus and the square. One more type of quadrilateral called as isosceles trapezium, that is a next part of trapezium. When the legs of the trapezium are equal in length, then that trapezium is called as isosceles trapezium. Don't forget this. In the next video, we will try to understand the numericals based on these properties. I hope till then you will be learning and understanding these properties for your betterment.